Hi, I'm Tim Martin. I'm an artist who loves to experiment and an earth science teacher who loves to explore. Through rock climbing and hiking, working in clay and photography, I'm always observing the natural world. If you're a student, teacher, or curious explorer, get ready for an adventure in science and art. Hi, in this video I want to demonstrate how to make supercooled water. Supercooled water is water that's still in its liquid phase below 0 degrees Celsius or 32 degrees Fahrenheit. So to start off with, I'm going to add in ice to my bowl here and put in a generous amount of salt. Now many of you may know that the salt on top of ice will depress or change the freezing and melting temperature of the ice, lowering it significantly. And so I have a thermometer in my salt, ice, and water bath here, and the temperature now is indicating that I've got this at about -7, -8 degrees Celsius. So this salt-ice mixture is well below the freezing point of water. Now, I'm going to clean this off, and it's important to use clean water and clean utensils for doing this. I'm going to pour some clean water into this metal cup. The reason why I'm using a metal cup is a better conductor for heat. Now I'm going to submerge the cup down into the salt ice bath, but keeping the inside fairly clean. Now I'm also going to slowly agitate it or stir it with my hand motion by just moving the cup around in gentle circles. If I don't move it, what's going to happen is the water on the outside of the metal cup may get cooler than the water on the inside and freeze from the outside. But I'm watching the temperature in the thermometer, and the temperature is now dropping. So let's come take a closer look at what's going on here. The temperature is now down at 5 degrees Celsius and still dropping. Getting colder. The temperature is now down at 2 degrees Celsius. Now the temperature is at 1 and 0, and it's still dropping. The temperature is now at -1 Celsius, and we can see that the water inside the cup is still in fact liquid. -2, and it's still liquid. Keep agitating it, and many people think it's not freezing because it's agitating, but really what I'm agitating it for or stirring it is to ensure that all the water is approximately the same temperature. We see now the temperature is at -4 degrees and the water is still definitely liquid. So this is what we call supercooled water, or water that's below its freezing point, and it's waiting to freeze, but there's nothing upon which for the ice to start crystallizing. Now I've got the temperature down at -5, so it's very cold, should be frozen, but it's not frozen. Now what I'm going to do is I'm going to add a small chip of ice into my liquid water and watch what happens. And just like that, it's frozen. And another thing that's very significant is, during the freezing process, you can see the temperature, where it had been down at -5, quickly rose up to 0 Celsius. The act of freezing warms the water, and the change from the liquid into the solid form meant that the water had to get rid of some of its heat, and it rewarmed the system, and so the water-ice mixture is now at 0 Celsius or 32 Fahrenheit. Thanks for watching, and I hope you join me again on another adventure.